Hello everyone, I hope you all are doing great. I welcome you back again into the system design series. So in this video, we'll discuss about another interesting topic, that is consistent hashing. So to understand the consistent hashing, let's take an example. Let's see what is the issue this concept is trying to solve with a simple example. Okay, so for that, let me just directly jump to the example. So let's say, for example, let's say we have a key value database. Okay, let's say that's a simple key value database, and in this database we are storing the key value pairs. Okay, now after a couple of time, let's say this database, the disk on this database gets full, and we are no more able to store the further data on this database. So in that case, what will happen? Simply we need to create another key value pair, another database, and then again we need to start storing the same kind of data. Okay, so that's the simple normal phenomena. But here the issue comes when we need to start adding multiple such databases. Okay, when the memory starts getting full. So let's say I have added another database. Again, I will be having key value pairs in this. So now when I needed to query a key value pair from this database, then how do I need to do that? So in that case, I need to just do a brute force approach, where I need to first start from the starting, like the first node I need to check whether it is there or not. Then I need to do another check. Then I need to do the third check, right? So it is again O of n time complexity, where I need to start looking into all the data in all the databases, or all the nodes present for that database. So that's completely a brute force approach, which is highly inefficient. So this is a prime issue that the consistent hashing concept is trying to solve. Okay, so let's try to understand this, how it solves. So now here, what we'll be doing is we'll be having an imaginary hash ring. Okay, so on that hash ring we'll be placing these database nodes. So what do we mean here is, let's say when we first create one of our database, okay, let's say we already have our 3 databases. Let's say those are the initial 3 nodes for our database, and if we need more nodes in future, then let's say we will be adding those nodes. But for now, let's say we are having these 3 nodes. So now what we'll be doing with consistent hashing? So first we'll be passing this node ID. Okay, so the node ID can be anything. We can compute it according to our requirement. So let's say the node ID here is 1. Okay, let's keep it simple, and let's take a simple example. Let's not make it more complicated. Let's say the second node ID is 2, and the third node ID is 3. Okay, so now what we'll do, we'll pass this node ID into a hash function. Okay, so it will pass into a hash function, and it will return us back with a hash value. Okay, and let's say the hash value here is 0. Okay, so for the node ID 1, the hash value returned by the hash function is 0. Now let's say the node ID for node ID 2, the hash value returned by the hash function is, let's say, 25. Okay, and let's say the node for node ID 3, the hash value returned is 50. Okay, so now what we will be doing, we can just imagine that we are placing these 3 values on a ring. So how do we look? So it will look like 0, then 25, and 50. Okay, so let's say there is a ring like this on which the values have been placed. Okay, so now let's say when this ring is formed and we have these 3 nodes of a database, and we got a new value to be inserted into the database. So again, let's say when we have a new key value pair, that key value pair will be now again sent to the value will be passed, that is, the key will be passed into a hash function, and we'll get a hash value. So now let's say the hash value we returned is 15 for that key which we needed to insert. So now here we'll check that where will the 15 lie in this ring. So then the 15 will lie between 0 and 25. All right, so that's the reason the 15, that is this key value, will be added to this instance of the database. So that's the simple concept of how we will be adding the data into the node. Okay, so now let's take another example, that let's say we got another key value pair, and we again passed that into a hash function, and we got a value of, let's say, 75. Okay, so this is a hash value we got for that key. So now this 75 will be where it will fall. It will fall after 50. So that will be before 0, that is after 50. Then that means it will come under this node. Okay, so it will just round up itself to this node. Okay, so that's how we'll decide which node the data will go into. and here it will automatically get distributed among the existing node. Okay, so that's the basic concept of how do we insert it. Now again, now how do you get back the data? So again, when we user needs to get the data, he will be passing the key. Again, the key will be passed into a hash function. When for a particular key, definitely the hash value returned back will be the same. Now let's say if the hash value is 15 for that key, so we know that where does the 15 lie? 15 lie, the data for this hash value will be lying in this node. So we will hit this node and we'll get back the data. So how does that will work? So here when we'll be querying the data, we'll be just hitting any one of the node. Okay, so let's say we hit this node. When we hit this node, it will calculate the hash value for that incoming key, and it will get to know that this key is found in this node, and it will directly make a call to this node and it will get back the data. So there are two network calls, one to any one of the database, and then if it is there in the same database, then it will be just returned back. If it is there in some other node, then it will just hit that node and it will get back the data from that node. Okay, so that's the basic process of adding and getting the data. Now let's look at a couple of more things here. So the first thing here we have is the replication factor, that is RF. So here while creating this database, we'll configure a replication factor. Let's say the replication factor here is 2. So what does that mean? Whenever any key value is stored on any one of the primary node, it should get replicated in one of the other node, so that for the data redundancy. So even let's say the key value is stored in this node, and if let's say if this node goes down, then also we should have another replica stored in another node so that we can get back that data. So that's the replication factor. So whenever the data persisted into the primary, then the primary will make sure that the data is also replicated into the next node in the same hash ring. So that's the replication factor. Now comes the very important concept, that is what will be the condition when there is a addition of a new node or when there is a deletion of an existing node. So in those conditions, how does the data is managed in the cluster or on the ring? Okay, so let's try to understand that. So here now let's say a new node got added into the ring. So when a new node gets added, it is again passed into through the hash function. We will get a hash value for that, and let's say it got added at this place. So now when this it's get added here, so let's say it is 0 as we already discussed, and let's say it was 25. Now this node which got added, let's say its hash value is 15. So now what will happen for whatever the data that were between 0 to 25 earlier before this node, if it was like 10 or 15, all the request would have been definitely gone to this node. Okay, but now what will happen if there is any key value pair, okay, that got already stored in 25. Okay, now for that there is a get request. So when that is passed, earlier let's say it was the value was 10 when it was added. Okay, let me just explain it again. So let's say initially just assume that we don't have this 15 node, only we have 0 and 25. So at this time we got a key value pair, and for that key the hash value that we got was 10. Okay, so now when the hash value is 10, so on this ring, this will be the right node where the data should go. So now the data was added to this node. After that we added a new node into the ring. So now the hash value of that new node is 15. Okay, so now when the user wants to get back the data, he will again send that key, we will hash it, and we will get back the hash value as 10. So now at this time when we see the value as 10, so which is appropriate node that will be storing this data? That will be the 15. Okay, but currently where the data is, the data is at this node. So this is a situation of ambiguity. So this is where what will happen in the Cassandra or this kind of database. As soon as a new node gets added, there will be the rebalancing of the data. Okay, so what will happen as soon as the new node gets added, the new node will immediately ask to its next node that whatever the data it belongs to this node, it has to pass it back. Okay, so the data gets passed back to this node, and it will have all the data that are between 0 to 15. So that happens, and it also the replication happens. So this change will not affect the whole cluster. It is going to affect only the next node present in the ring, on the ring. Okay, and same thing happens again. Whatever the data got moved, it will be removed from this node, and the replication will changes. So whatever the change will happen, that will be happening in between just these two nodes. So when we the next time whenever we need to get the data for a particular key, that let's say for example this one, now automatically the read will go to this node, and it will definitely have the data, and it will return that back. Okay, so again the same phenomena happens when a node got removed. Let's say this node got removed. So now in this case the data is already replicated in these nodes. Okay, so those nodes will automatically rebalances and they just transfer the data to the other nodes according to the hash structure. Okay, so this is how the whole an overview of how the databases like Cassandra works on the concept of the consistent hashing. Okay, so let's look at a couple of things here. The same thing which we have discussed now, I have that on in this slide, and then next I will show you a simple demo of exactly how this works. Okay, so when a new node joins, which we just now discussed, a new instance registers with the console. So here in this demo, I'll be using console as a service discovery, where all these nodes is orchestrated through another server, that is the console. So here the role of console is, whenever a new node is added, it will get registered with this console, and the console will keep track of all the nodes that are present here. Okay, so any new node that got added or any new node that got removed, it will be known to the console, and these nodes will get adjusted according to the whatever the discovery they will be doing in the console. Okay, so I will show you a demo of this after this. So console will be used here for orchestrating the nodes in the hash string. So that's how I have implemented it to explain it, but it can be implemented in some other way also. Okay, so here when a new instance registers, it registers to the console. Okay, so under the IP and port, and now the existing nodes detect the newcomer. So every node on this hash ring has a scheduled job after every 10 seconds that will query the console for checking that whether any new node is added or any node is removed from the hash ring. So the moment the query is done, it will see that a new node is added. Okay, from the database, and they will make a check that whether the new node is added after the existing node. Let's say now a new node is added it here. So now this node will come to know that this is a new node and it has to get the data from this node. Okay, so that's how it will work. So now here all the nodes update their local hash string. So every node will have the data of this local hash string. Every node calls the hash string.add node. So murmur3 is the hashing algorithm we are using, hashes the new node's ID string, and the resulting long is inserted into the concurrent skip list map. So this is a data structure I'm using in this demo. So this data structure is a map used in Java that automatically sort the data that is added on the basis of the key. Okay, so it automatically sorts the data. So the sorted map instantly repositions the node's ownership boundary. Okay, so the new node calculates the token range. That is, it will calculate that what amount of data it has to pull from its successor node. That is, when a node is added over here, it needs to pull all the data from this node, which will fall under its boundary. Okay, so here in our case, that is from 0 to 15, whatever the nodes were there, whatever the data were there, that it has to pull it. So that's the fourth step. Then the fifth step, after the calculation, the data is transferred from the successor node, and the new node stores the data and initiates the replication. So that's how the data moves when a new node is added. Okay, what will happen when the new node is removed? So again, the console detects the missing health check. So the remaining nodes detect the removal, and the dead node is removed from the ring. And as soon as the dead node is removed, the successor nodes promotes the replica data to primary. So what do we mean here is, let's say when this node is present, okay, initially when this node is present, it will have some data. Okay, so that data will be replicated in this node as well. Okay, as a replicated data. It's not a primary data, it's a replicated data of this node. Now what happens? This node goes down. So the moment this node goes down, when the recalculation happens, this node comes to know that its previous node has gone down, and its previous node's replicated data was present with this node, right? So now what will happen? This node will promote its replicated data into a primary data. So this node will be having its primary and replicated. So the replication data was coming from this node. So now as this node is not present, so this node will automatically replicates its replicated data to its primary. So now whatever the hash queries goes to this node, so that it will be able to get that data and send it back. Okay, I hope you are able to understand here. Replication is re-established. So that's the phenomena happens when the node is removed. Okay, so how a node info is calculated? So that's again regarding this demo. In this demo, the node ID is calculated using the IP of that host where it will be running and the port. So combination of that, it will create a node ID. Host will be the IP, port will be the port of that machine on which it is running, and the hash value for that node will be the node ID. So the node ID is passed into the more3 hash function, and it will be returning back the hash value. And is active is always set to true, as the node will be activated. Okay, so that's all I need to discuss here from this theoretical point of view. Let me now get back let me now show you the demo. So in the demo, we'll discuss how the whole architecture is working. Okay, so let's look at the demo for this consistent hashing. So in this demo, I have created a simple clone of the Cassandra kind of database. Okay, so that's a key value database, key value distributed database. Okay, so here when I created this database using the concept of consistent hashing, I just observed a issue, or you can call it as a bug or an issue. So let me explain you what was that, and then what was the solution I have added to it, and then we'll start the demo. So here, as you know, now the size of the ring is from 0 to 2 to the power 32. Okay, so whatever the value of 2 to the power 32, that will be the size of the ring. Okay, so now whatever the nodes, so what do we mean by this is, let's say if we pass a value of a node ID. Okay, so let's say node ID here, as we discussed, is the IP and the port. Okay, so let's say this is the node ID for one of the node. We will be passing this node ID into a hash function. Okay, so this node ID will be passed into a hash function. It is going to return us the hash value. Okay, so that hash value will be lying between 0 to 2 to the power 32. Okay, so whatever the value it will be there, it will be lying in between this. So now when this value was arrived, let's say it has given some random value, okay, the hash value for this node ID. So that will be placed on the ring. So when this was done in a normal fashion, it was giving some bug. So what was the bug here? Let's take a simple example. Let's say the ring value is only between 0 to 100. Let's not take 2 to the power 32. Let's take 0 to 100. So when the first node ID was passed and we got the hash value, so the hash value was like we were getting the hash value like 50 for the node ID 1. For node 1, the hash value was 50. Then we passed the next node 2. We added the second node in the ring, and we got the second value as, let's say, 80. And we passed the third node into the hash value, like we added the third node into the ring, and it gave me a value like, let's say, 100. Okay, so now here if you see, if we place these onto a ring, you will see that the first node is getting the highest space in the ring from 0 to 50. That is around the 50% space in the ring, right? Now what about this? This is getting only from 50 to 80. So that's around 30%. 30% space on the ring. And this is getting only around 80 to 100. So that is only 20% space on the ring. So now because of that, whatever the key value we were adding into this database, so maximum of them were going into this ring or this node. So these two nodes were getting very less data, okay, because of the ring distribution. So here, if I draw a simple ring here, so let's say I have a ring, okay, let's say I have a ring like this. So if the node 1 is lying at this point, which is getting around 50%, so that means the node 2 is lying somewhere here, and the node 3 is lying somewhere here. So the most of the data was getting added in this section of that is in this node. Basically this node was getting the highest amount of data. Okay, so because of this issue, I needed to introduce a virtual node concept here. So what we are doing, physically we will be having these 3 nodes. Okay, so once this node is created, we are creating additional virtual nodes in this. So because of that, what will happen now? Let's say I have added around 100 virtual nodes. So this is going to take further spaces. Okay, so all these virtual nodes belong to this first node. Okay, now let's say we did the same for this also. So I added 100 virtual nodes for this. Now this virtual node, what will it will do? It will push this node on the ring to the higher side. Okay, so now let's say this was removed from here and it moved over here. Okay, so now I added next 100 virtual nodes. These are not actually there in the database, in the distributed database, but they are virtually present just to adjust the ring. So now when I add 100 more here also, then what will happen? The first node, which was getting the highest space on the ring, will also move further down in the ring, And now because of this virtual node, we were able to like equalize the space among the existing or whatever the nodes were added. Okay, so that is a fix we did to improve the space for each node on the ring. And now because of that, now whatever the data will be added, that will get equally distributed among these nodes. Okay, so I hope you were able to clear this concept. I'll be like pushing this code to the GitHub repository, and you can look into the code. You will be finding the same concept or the same logic implemented in the code also. So now let's start the demo and let's see how the overall concept is working here. Okay, so for that, let me start the application. So here it's a single application, single Spring Boot, Java Spring Boot application that I will be running in different ports, that is multiple instances of the same machine. So each instance will act as one node in the ring. So let's say here, let me start with the first one. Okay, so to like for the service discovery, that is which is acting for the as an orchestrator, we are using Consul. So I have already started the Consul as a Docker container. So I'll be passing that command in the resources file. So you can use that. So this Consul will act as a service discovery. Now, as soon as we started our first instance, you can see that the first instance got registered over here. Okay, so the moment we'll start the new instances, they will start getting registered here, and every instance will keep on checking for a new instance whether added or if a instance is removed through this Consul, which is acting as a service discovery here. Okay, so let me now go to another terminal and start the next instance. Let's say 8081. Okay, so the moment it will get added here, you can see now we automatically got the second instance in the discovery. Okay, so again let me add the next one, 8082. Okay, so we have our three instances, that is three nodes on the ring. Okay, so all the three instances are running. Now if we go and check for the ring, you will see that this is a ring that got formed, and here 8082 is at the first position in the hash ring, and then this is at the second position, and this is at the third position. So you can imagine them on a ring. Now if you look at the data that is present, all of them don't have any data currently. Okay, so this is 8083, which is not running, and this is 8083. So 8081, 82, and let me also run the 8080. Okay, so all the three instances are running and they don't have any data right now. So here we'll have a primary and one replica. So if we go inside the code in the application.properties, here I have added the replication factor. So the default replication factor is 2. That means one for the primary will be the one node in which it will get persisted, and it will also replicate that into one more node. So we can change the replication factor here if we need more replication. And here this is the Consul configuration, so that this application will get registered in the Consul. That will help us in service discovery. Okay, so these are the few configuration added here. Now if we go to another terminal and start adding some data, let's say I'm adding this data. So here you can add the data to any node. So you can send the data to any node. On the basis of the hash value of that key, the data will get automatically added to the appropriate node on the ring. So here I'm sending a key value that is mobile and iPhone. So this is when I have sent, you can see that right now I have sent it to 8082. So let's check that whether it is going into 8082. Okay, so now this is the primary for 80 for the mobile, and mobile is the key and iPhone is the value. So if this is the primary, if we look at the ring, so 8082 is the first one, and then we have 8080 at the second place and 8081 in the third place. So now if 8082 has the primary, then with the clockwise, its replica will be present in the next node, that is 8080. So if I refresh this, you will see that the replica is present here. Data got replicated automatically in the next node. So if you see this one, we will not have any data here. So let me add a few more data. Okay, so let's say I'm adding this. Okay, so now let's check where this got added. Okay, so this again got added to the first node, and the replica got added over here. So let me run a script that will add the multiple data at a time. Okay, so it added around 15 key value pairs. And now if we go and look, you'll see that. Okay, so these are the primary. So around, let's say 1, 2, 3, 4, 5, 6, 7. There are 7 primary data in this node. So these 7 should be available in the next node's replica. Okay, so if you go here, if I refresh this, you'll see that all those 7, 1, 2, 3, 4, 5, 6, 7 are present here in the replica of the next node. So now this node's primary are these 1, 2, 3, 4, 5, 6, 7. So these 7 should be present as a replica in the next node. Okay, if I refresh this, you will see that all these are present over here. Now this node's primary, that is keyboard and monitor, should be present as a replica in the first node because it's a clockwise. The ring is a clockwise. So here you can see the keyboard and monitor are present here in the first node as a replica. Okay, so I hope you are able to understand the concept here. Now let's do another scenario where we will add one more node. Okay, and then we will see in the ring where the node got added, and then we'll see how automatically the data will get adjusted according to the ring. Okay, so let me go here and let me add another terminal. Okay, so let's say 8083. Okay, so let me just give 10 seconds here because after every 10 seconds the scheduled job will run and it will check for the new nodes in the ring. If there is any new node, then it will automatically trigger the data rebalancing. Okay, so I hope 10 seconds have been elapsed. So here if you see here, we already have 4 nodes, and if we see here, so the node 4, that is 8083, has been added at the second position. Okay, so that means now 8083 is going to make a call to 8080 to get its set of data. Okay, so I hope you are able to get. Earlier, whatever the data that was between 8082 and 8080 were going to 8080, right? Now we have another node in between. So now it will ask for the data to 8080, whatever the data that belongs to 8083, that will be automatically added to 8083. Okay, so let's see whether that automatic distribution will happen or not. So here 8083 is after 8082. So let me just duplicate this, and here if you see now, this is 8082 has these data. Now if I make it as 8083 and if I press enter, you will see that earlier, no, okay, so I think it is 8080, right? 8080 is the next one, right? So 8080 had these things, Bob, TCS, Delhi. Okay, so these are the data which were already there. Now from this, Delhi and Google, the company Google and City Delhi, have been moved to the 8083, that is the previous node from this. So if I refresh this, you will see that these two data will not be present here because those are moved to the previous node, and the same thing, and these two, Google and Delhi, now should be present in the next node, that is, which is the next node, that is 8080, that is this node itself. Okay, so if I refresh this, you will see that Google and Delhi are now the primary of this, and now they become replica of the next node, and they have been removed from the primary. Okay, and this one got all the replica. Okay, so these are the data of the first node, because now this is the second node in the ring. So so this node's primary will be the secondary of 8083. Okay, so that's the reason. If you see here, 8082 is the first node, and this is the primary data of this, and this data has been replicated over here in the next node. Okay, so here I just missed to show you one more thing, that is the get operation. So here let's say we have these data that are present in, let's say, this node, that is 8082, and now let's say I need to get this data, let's say mobile, as a key. So it should return me iPhone, right? So here if I enter this, so here I'm getting the iPhone. So here it doesn't depend on which node you are hitting. So you just need to pass the key and it will return the value. For example, now here I am hitting the 8082. Right now the data is also in the 8082. So let's see whether we'll get the data back if we hit some other instance. Let's say I'm hitting 8080. Okay, so even if I hit 8080, I'm getting the data exactly what the value was for this key. Okay, so let's say if I just hit order 003, again this time let me hit it to 8081. So here again I got the data back as a tablet. So here we can just place a single load balancer, and we can the load balancer will automatically load balance the request among the nodes on the ring, and you will be able to get the data. Okay, So that's regarding how we can get the data from the database. So I hope you were able to understand this concept of consistent hashing and how it is implemented in the database like Cassandra. Okay, so this is not exactly how the whole actual Cassandra is working, but this is a simple clone of that. Okay, so I'll be pushing this code to the GitHub. You can just look into that. Okay, so let's catch up in the next video.